We've talked a lot about hashing and what hashing is, but how do you get a hash? How do you capture a hash in real life? There's a tool called Aerodump. And it monitors Wi-Fi traffic and displays it on the console. I have set up an access point and the client. And using AirPlay, we are going to de-authenticate Crunch is a commonly used tool for generating password lists. Once you have it downloaded and installed and you open a terminal, all you need to do to run it is type crunch followed by the minimum number of characters you would like in a password, followed by the maximum number of characters you would like in a password, and then followed by at least one option. For example, we're going to generate every possible variation of an 8-digit numeric password. So we'll specify our car set. That's a user share crunch car set list, and the particular car set is numeric. And if we were to let this run, it would generate 858 megabytes, which is not a lot. That would end up as 100 million possible variations, 100 million passwords. And although that may sound like a lot, it really isn't. It's quite common nowadays to see password dictionaries with billions of passwords in them. Although they can be quite inefficient, because one password list is not going to work for every person. No, so generally attackers will generate custom lists designed to target a particular person after doing a lot of reconnaissance on them, online. Maybe they'll do it in person, physically, maybe break into a house or go through somebody's rubbish to try and find paperwork or something like that would give maiden names, first names, last names, addresses. Online you could find out a lot about a person too. So at this time we'll generate a 10 character password, and we will use the Wi-Fi WPA car set rules and share crunch branch car set list, and I think it's mix alpha numeric all for symbols and space. And if we were to let this run, it would generate 11,500 petabytes, billions of gigabytes. Absolutely incredible. But like I said, they will do like a lot of reconnaissance on you online or whatever, and let's say for example they'll create a list of pieces of information about you, and then they'll write a script that will call this line we see in front of us, except change the following argument, which is this T, which specifies a layout. Then they would add in this case I'm going to say a surname. You can replace that with a real surname, 2 percentage signs, and this character. When this runs, the percentage signs will be replaced with digits, and this little character at the end will be replaced by symbols. And I won't let it run first off, we'll just look. Less than 1 megabyte. 3,300 different passwords. And it would generate this instantly. If I were to run this again, it will wait 2 seconds and then just run it instantly. Yes. So you can imagine a lot of people would be vulnerable to this particular dictionary, with their surname, the first letter uppercase, followed by the last 2 digits of the year of their birth, followed by a symbol.
So for the purpose of this demonstration, let's imagine that a popular website has been attacked, which has resulted in thousands of passwords and usernames being leaked onto the internet. On your right hand side, you can see a dictionary of over 14 million passwords. This is a dictionary that will be very similar to the data breach that happened in 2009 on a website called RockU. They specialise in creating widgets for various social media platforms like MySpace and Facebook. The company used an unencrypted database to store user account data, including plain text passwords, for its services. RockU would also email the password unencrypted to the user during the account recovery. Special characters were not permitted in the passwords, and passwords could be as little as 5 characters in length. Taking information acquired from the password dictionary, a secondary attacker, which in this case is someone who uses information that was already leaked from the first attack that we already mentioned, then tries to brute force a password. We have created our own password cracker, which you can see here below. So what you can see here is the actual attack taking place, and the attack vector being shown is a type of brute force attack called a dictionary attack. So as it's running in the background, I'll try to explain some of the code. The main method, which is up here, contains a file path to the RockU password dictionary. This particularly long string right here, hash to crack, is actually a raw hash which represents the password John 321 exclamation mark. This is the password that we're trying to find from the dictionary we already have. The read file method opens a text file, reads out lines of the file into a string array, and then closes the file. It then returns the passwords. The crack method creates a SHA-256 class object, which then tries to hack the hash of the password. It does this by looping within the password dictionary. The byte array hash value that you can see here, there, is appended to the string hash builder using the string builder method. As a method of tracking progress, we included a test that enabled us the ability to monitor the program as it looped through 14 million passwords. Now, as you can see, that it's kind of already finished. We did that purposely because, as you can imagine, looping through 14 million passwords takes a very, very long time. And so then if the password matches, which it did in this instance, it displays password found John 321 exclamation mark, which is exactly what we were looking for. And if not, the program will display password not found. It's quite obvious that encryption is not always enough for securing your data and personal info. If using passwords, they must be complex and long, using an array of characters, numbers, and letters. Ideally, you will also want some form of two-factor authentication, and even then, is that enough? An interesting example of a dictionary attack was the Conficker exploit. Also known as Down Up and Keto, Conficker is a computer worm targeting the Microsoft Windows operating system that was first detected in November 2008. It uses flaws in Windows OS software and dictionary attacks on administrator passwords to propagate by forming a botnet, and has been unusually difficult to counter because of its combined use of many advanced malware techniques. The Conficker worm infected millions of computers, including government, business, and home computers in over 190 countries. Most interestingly, it infected a lot of Department of Defense agencies in the likes of France, the UK, and the US itself.